Okay, as I start this problem, jumping around the room a bit, before I do anything, I do notice a key distinction between the start of problem 4 versus the start of problem 3. So, HT, what can you see what I'm noticing?
Is that they're both being divided?
So that would be a similarity. I'm noticing something different between the two problems.
It has an interval.
There we go. Item 2 points for HT. Item 3 is an antiderivative only. Item 4 is an integral. But the fundamental theorem says the first step is to think of this formula as whatever. That's this. And then realize that instead of computing the integral, what we want to do is we want to go find this other formula. So how is the formula here in brown related to the formula in purple?
The formula in brown is the same as is part of the formula in purple. I don't know how to say it right, but I kind of understand what I'm saying.
You're okay. I kind of misled you by the question, sorry. What I was trying to get to is, whatever this formula is I'm currently circling, that is the derivative of the purple. So the purple is the antiderivative of the brown. So our first step in computing an integral is to find an antiderivative. Before we can do this integral, we need to find the antiderivative of what's inside. So we need to do this first. Find the antiderivative. So please write what I'm writing on your paper, 2 for Will. Write that on your paper. We've got to find the antiderivative before we find any integral. That's the first step. Cool? Okay, next thing. Raise your hand if you need, well, I guess I'm hoping no explanation is required. That doesn't match any formula right here. There's none of those 5 blue formulas look anything like this. None of the 5 look anything like that. So that's a dead end. So since the formula doesn't work, I want to try use substitution. Remember, for our class, it's pretty straightforward. Either the formula will work, or we try use substitution. We'll do one more thing after that, but that's it. So only 3 options. Questions? Cool. Okay, for use substitution, I must have 2 functions that are being multiplied. And just a trick I've learned from experience. When I have a root in the bottom, I don't always change that, but what I'm noticing is, Tara, what's the derivative of 1 minus x squared? Negative 2x. Hey, that's pretty good news, because there's 2x.
Oh.
That's what I'm looking for. Like before I do anything, I'm looking for a little connection somewhere. So I see that the derivative of this is almost exactly the same as this. So I'm like, oh, that means my choice of u is probably going to be that right there. That's likely my choice of u. Thank you. That's hilarious. It's probably obvious. The reason I circle so much is if I'm not making a video, I don't do that because I can just point.
Yeah.
But in the video, they can't see my pointing. So I have to do something so that as I'm talking, you can see what the heck I'm talking about. Does that make sense? Like I've watched some of my videos, like I can't even tell what I'm doing because I keep talking about things and pointing like you can't see it. So that's why I circle so much. Yeah. Good question, please.
What happened to the square root?
We're going to handle that as well. But what I did in the beginning is this. So HT, are you okay that I recognize that in order to calculate that integral, I must find an antiderivative first? Perfect. So equals Are you okay that none of the formulas work, HT?
Yeah.
Perfect. So I just went looking. I'm doing a trick I didn't show you previously. I just look at what I have and say, can I identify something whose derivative is another thing? And I did. The root, we'll worry about that in a minute. But temporarily, I just focused on the fact, we'll just circle one star, that the yellow, the derivative of the yellow is indeed the orange, pretty much. That's a really good sign U substitution will likely work. Now we're going to go through the formal process. Like I've done enough to feel comfortable, I'm going to go through the formal process. So, root on the bottom sometimes works. More often I need to move it. So I'm going to move it. So write on your paper this. Antiderivative, 2x, that's over 1, multiplied by, this root on the bottom is the same thing as 1/2 power. So when this whole thing moves to the top, it becomes 1 minus x squared to the negative 1/2. I don't really need the over 1 anymore because I don't really have fractions, so that looks good. Question, please.
Leave it as the 1 over 1 minus the square root to the 1/2 instead of the square root, and you can use the 1 over rule.
Leave it as 1 over, and then use the 1 over rule. Let me show you why that won't work. Good comment. So if I would have done this, I would have said, oh, this is the same as, which it is, 2 for Kaylee. This would have been 2x over 1. And then it would have had 1 over square root. I want the whole room to answer this. Okay, so Kaylee correctly noticed that that would give us this form right here. If that's our form, everybody, hands up, what would be the choice of U? Remember, U is always the something. U is the something. So if we write our second multiplying function like this, which makes our second multiplying function this form, what would be the appropriate choice for U? Come on, more people. What is the appropriate choice for you, Cecily?
The square root of 1 minus x squared.
Okay, raise your hand, please, if you noticed that. 2 points, 3 for Cecily. The derivative, listen close. The derivative of root 1 minus x squared is not going to look like this at all. So wrong choice. The derivative of our choice needs to look like the other multiplying function. Does that make sense? Yeah, that's why I didn't want to do that. Not wrong, I can just tell it's leading to a dead end. Please.
So instead of just being 1 over square root of 1 minus x squared, it's just going to be 1 over u.
This would become 1 over u for sure. The trouble is, when we take the derivative of our u, we're not going to get this, which is a dead end. 2 points. So let's erase that. So hands up, everybody. What is our appropriate choice for you? Like, the orange looks great. What is a good choice for you, given that we're looking at this antiderivative right here? What's a very good choice for you? Come on. There we go. This is a very narcissistic discussion. What's a very good choice for you? Forget about your x. Xander.
1 minus x squared.
1 minus x squared. So this is, again, this column, this is your main work. Come over to the right, do the u stuff. So u is equal to 1 minus x squared. Please raise your hand if you knew that before Xander said it. 2 points, 3 for Xander. Got a really cool sign here as well. Mikkel Dahl and Billy Lysenko. I don't know if you've seen that movie. It's called The Help. Anybody seen this movie? You need to see this. Good movie? Yeah, a really good movie. In the movie, there's a maid who takes care of this little girl. And every day she has this little ritual where she talks to the little girl trying to help her build confidence. And she says, now remember, say it with me. Like, she says, you is smart, you is kind, use substitutions. That's good. Never mind. Okay. Read the name for me.
Claire Johnson.
Clay Johnson.
Claire.
Oh, she's not here.
Okay. Next.
She gave us that.
Yeah, she doesn't really
She doesn't listen.
come to hear it at all. Anyway, but that's good. Okay. Everybody good here? Cool. Next step, we have our U. Let's go to Sam. What's the next step, Sam?
Um,
So we have our use, we have to differentiate both
Perfect.
sides.
You got to go d dx to both sides here. So I go d over dx of the u. That's not really going to change anything. So Sam, when I do d dx of this, what do I get?
You should get negative 2x.
Perfect. 2 points. Take 3. Take 4. Okay, cool. Perfect.
That puts
Sure. Take a point. All right. Questions?
That's not work.
There's no system. It's all random. I will confess one thing. If I know that I've gained confidence that you're going to score well on tests, I'm very willing to give you lots of extra credit. Like, yeah,
I
you.
saw a higher score than her though.
Oh, that was cool. So she needed the points. That was mean for. That wasn't mean for me. Okay. Delete the last.
Yeah,
Delete
take
the
away
last.
your
Delete the
tickets.
last 30 seconds. Okay. We good here? We good? Emmeline, what do I do now?
oh my gosh, don't you wanna make it so you move dx over to the other side, so it's
Too much right, Emmeline. Doing great.
du equals negative 2x dx.
Doing really well. Okay. Look. Once we know we have made the correct choice for you, this is such a good discussion. Like I want to have the English department. I want to have the English department just sit and just like it sounds great, right? Like it's like the best ever. Like once you've made the best choice for you, it's a good choice. Now you just use the equal sign. You just keep finding things that are equal. Matthew, we got to take stuff from over here and use it to make replacements over here. So tell me one replacement I can make really quick.
the 2x and the dx.
Close. I got this negative I got to worry about. So I just move that. I just say negative 1 multiplied by du is equal to 2x dx. 2 points for Matthew. Chris, what else can I take from over here and use over here? Just look for items that match up. All you're looking for is things that are the same.
The 2x dx.
So this, definitely I can do that. There's one other one I'm hoping you'll see. Can you see anything else that's the same over here as over here? 2 points. Let's go to Lucas. Do you see something that's the same?
Isn't the parentheses just you?
Yeah, right here. So we make that substitution first. And now we can reorder our multiplying factors, which we typically will do. We put our u first. U to the negative 1/2. Multiplied by 2x dx, 2 points for Lucas. Matthew, maybe. Now what can we do? Oh, please, Kim.
Why did you move the negative 1 over there to the equation? So multiplying constant can be different still, right?
Yes, but we do have to make a legal substitution. Like I can see that this multiplying negative 2 is not going to cause me any trouble because that is really, like this part right here, that's an exact match for this other than the negative. So I know I'm in good shape, but I do have to make a perfect substitution. So now what can I do with this, Matthew, maybe? Like what else can I change here? Like I want to take stuff from over here And I want to replace stuff over here using the equal sign.
Did you do D?
I want to take this. According to what I have over there, what is this orange box exactly the same as?
Negative 1 D.
-1 du. 3 points for Matthew. So this will equal now the antiderivative u to the -1/2 multiplied by, don't forget parentheses, -1 du. -1 is a multiplying constant, so we can pull it out. That is what you call success. We went from a very complex antiderivative to a very simple antiderivative, which is the goal. Question? So MJ, what do we do now? The blue sheet is exactly the place to look. Notice you looking at it, because this antiderivative fits one of the blue sheet formulas. So according to the blue sheet, MJ, what is the antiderivative of u to the -1/2 du the same as? So use the power rule, keep going, doing great. So you have u to the -1/2, that's going to become instead u to the, there we go. This becomes u to the -1/2 plus 1 divided by -1/2 plus 1. 2 points for MJ. Questions? Which is, this is positive 1/2 power. This is positive 1/2. 1/2 power means square root. Dividing by 1/2 means multiplying by 2. -2 square root of u. We have successfully found, we're not done, but we have successfully found an antiderivative. Please.
Wouldn't you also need plus?
Oh, because we're doing an integral, the plus c is going to add to make 0 anyway, so you don't need to write it. Please.
How do you get -2 and a square root if it's just u to the 1/2 over 1/2?
Let's write it out so we can see it better. So what I have is, 2 points for Blake, good question. I have -1, u to the positive 1/2 power, and the whole thing is divided by 1/2. Are you okay with that?
Yeah.
Perfect. 1/2 power means square root. Okay with that?
Yeah.
Dividing by a fraction means multiply by that fraction's reciprocal. So I have this. I have square root of u. The fraction's reciprocal will be 2 over 1. If I multiply those 3 factors together, I get this.
-2 to the square root of u. Okay.
Again, I'm doing an integral, so I don't need to worry about the plus c. For Blake, question? Sweet. Okay. If we were to take our u value here, in fact, let's do that real quick as just a quick check. So let's, running out of room. So if we were to go back, we'd say, okay, this is the same as -2 square root of 1 minus x squared. And then we would take the derivative of this, and we should end up with this. So let's check that real quick. 8. Negative 2, 1 minus x squared. So we found the antiderivative to be negative 2 square root 1 minus x squared. So Jackson, if I take the derivative of that, what would the next line say?
Both my constants, I take 2 out, then 0. And then, what is it, 1 over 2, the square root of 1 minus x squared.
Keep going, Jackson. Great.
And then it's d over dx of 1 minus x squared.
3 points for that. Jake, what's next?
You don't need to worry about the 1. Well, you could probably bring the 2 over, so you would have, cancel out, well, not cancel, but.
Thank you. Yeah. Divide.
Yeah, divide out the 2's, so you'd have negative 1 over square root of 1 minus x squared multiplied by negative 2x.
Perfect. Worked. Exactly what we started with. Exactly what we started with. Questions? Cool. So the check works. Now we're going to do the integral part. So here's how we do the integral. We go back to the story, which does seem to resonate with some of you. We are going to forget about your x. Make it all about you.
Wow.
You are the most important part of this equation. You is the most important part. That's the other fun part about this lesson is you get to say you is, and it's fun to say you is. So we started the problem with, okay, look, your paper should show that, okay, and you should be now at this junction here, which means we kind of start over now. So we write the antiderivative from 0 to 1/2 of 2x all over the square root of 1 minus x squared dx. We know that the choice that we made was 1 minus x squared. We need to make it even more about u. We do not go back to x. We make it all about u. So let's go to Chris. We had values of x here. We had values of x here. We had stuff involving x here. We have stuff involving x here. Those are x values. So I want to say if my x is equal to 0, what is the equivalent u value? And we use this. So how do we convert from an integral using x equals 0 to an integral using x equal u? It says right here, if you want to find a value of u, there's your formula. So if your x is 0, what's the u value? 1. So u is equal to 1 minus 0 squared, 2 points for Chris. U is equal to 1. And Matthew Harmson, what's the other value of u? So the x is 1/2. So we plug in the x. What's 1/2 squared, Matthew? What does it mean to square something? Yeah, so what's 1/2 times 1/2? No, that would be adding. 1/2 plus 1/2 is 2/2. 3 points though, appreciate the humor. Sam, what's 1/2 times 1/2?
It's a fourth.
There we go. Sam, what's 1 minus 1/4? 3/4. We have our new limits. So over here, this is now the same as the antiderivative from a u value of 1 to a u value of 3/4. When we made all the substitutions over here, the antiderivative we had was actually right here. So we write that down. So there's a negative 1 out front. And we had u to the negative 1/2. du. Questions? Please.
Why did you like negative 1 to 1/2? Like,
What I did, Ellie, is I remembered that when we were just working on the antiderivative, we eventually had this right here. So when we had changed out all of the x things, like when we had replaced this and this and this, this is what we ended up with over here. You good there?
Yeah.
Good. But because we're doing an integral, we can't really forget about the limits. I just kind of left them alone temporarily. I need to include those as well. So what I did is I kind of jumped back in right here and said, let's just write down that step, which I did right here. There it is. And let's include the limits this time. So now this integral, this is all u. There's no x's anymore. That makes sense?
Yeah.
3 points. Anybody else? It's rough.
That's it.
That would. Never mind. Okay. Questions? Okay, so back to the fundamental theorem. Fundamental theorem says, right here, if I'm integrating some formula, right here, integrating this, rather than integrate this brown, I'm going to find the antiderivative of the brown and plug in the limits. So your next line should say, move that out of the way, equals negative 1, and we can shortcut it because we've already done it. We figured out that the antiderivative was this. So let's just write that. So negative 2 square root of u. And then the bar, indicating that we need to plug into that formula 3/4, and we also need to plug in 1, like that. Question? Please.
Need the plus C.
Remember, it's been a couple of days, but when we did a previous example last time, we showed how that if we're doing an integral, the plus c will combine with a minus c and end up being 0 anyway. So anytime we're doing an integral, the grader doesn't expect to see c. 2 points. Good job, Emmeline.
Thank you.
Anybody else? Okay, cool. So now let's do that. So we gotta get this out of the way. So I write negative 2 square root. Upper limit is 3/4. Subtract. Put a parenthesis. Negative 2 square root. Lower limit is 1.
Whoa, time out.
Time out.
Don't you normally put your smallest limit on the bottom, so shouldn't that be 3/4 on the bottom?
2 more points. What we always do is right here in the fundamental theorem. We always take the upper limit, which is typically the larger number. It doesn't have to be. It doesn't have to be the larger number. It's just whatever the upper limit is. So when we began the problem, everything looked kind of familiar. You know, 0 is the lower number,
Yeah.
1/2 is the larger. You okay with that?
Yeah, and then when we plugged in.
Yeah, when we made our U substitution, we ended up with a little bit of an uncomfortable situation.
Okay.
But it's okay. We don't have to do anything if we don't want to. If you want to switch the limits, you can. You simply have to multiply the whole thing by a -1 if you switch the limits. And then it's still the same. So I could have done that and the negative would have gone away, but either way. 2 more. Anybody else? Cool. So when you have the root of factors, you can split the root. If you have the root of terms, don't do that. So this is the same thing as root 3 divided by root 4. And root 4 is 2. Root 1 is 1. So we end up with negative root 3 plus 2. We are finished. Bit of a lengthy discussion. Facts. Lost Gabe. Yeah, we really lost him. Like he's asleep. Okay, let him sleep. As they said in the old days, he's just tuckered right out. So, okay. What's that? Oh no, he was with me. I noticed. That's why I was a little surprised when I suddenly put he lessons. That's okay. Anybody else? Please look.
So this is kind of not important, but why is the symbol used for substitution?
Oh, the joking answer is because it's a lot more fun to say it's all about you and you is and all that. It's fun to talk that way. The real answer is when I was taught this process at BYU, my professor used the letter U, so I got accustomed to that. You could use the letter W, Z, alpha, fish, pomegranate, whatever you want. Fish substitute. Smiley face.
With the quick fish.
They might, because they're really big on like, hey, the students should be using official math notation.
They
don't have any sort of humor.
No. Have I not talked about the, oh, you gotta stop the video, I'm gonna say terrible things.